Good afternoon, ladies and gentlemen. My name is Iurii Vakaliuk, and I would like to present you a demonstration house cube. And the cube is assumed to be the world's first building which is entirely constructed of non-metallic carbon reinforced concrete. So the result, the erection of the building, should represent the whole process, the process chain that can be implemented in practice. The total area of the cube building is about 220 square meters. And first of all, I would like to start with the front view of the cube. On the left side, you can see the main shell, the so-called twist, the main load-bearing part of the cube building. On the right side, you can see so-called box. It's the part of the building that contains laboratories that are designed to provide some special experiments in order to research other aspects of the textile reinforced concrete. The twist is also designed to be like the main roof of the building and contain a special space, a multifunctional space that can be used like space for the presentation, for some lectures, or like the exhibition hall for the latest achievement in the field of textile reinforced concrete. As I already told, the box is designed to keep special laboratories for the further tests, and the main feature of the box part is that it's designed completely from precast elements made of textile reinforced concrete. If we change the point of view, so you can see that twist has also two parts, a north part and the south part, and in between we have a top window designed specially to provide enough light inside the building. Also, you may realize that the cube building located in quite beautiful place in Dresden. Thus, you can see it from different points of view, and it really represents the cube like the latest achievement in the field of textile reinforced concrete. After the general description, it's time to go inside the load-bearing shell. From this slide, you may see quite complicated inner structure of the load-bearing shell, and that's why this part of the building is considered the most critical and the most important. As it was mentioned before, we can see a load-bearing roof of the whole building that contains the left part and the right part, south and the north part of the load-bearing shell. Thus, we have a load-bearing part as well as weather shell. Weather shell designed to cover the whole roof and provide the general appearance of the building. As you may realize that the load-bearing shell is designed like a hollow section inside, and that's why we have enough level of stiffness, and the self-weight of the load-bearing shell is reduced. In order to form such shape, there were designed almost a couple of thousand of specially preformed EPS blocks. Additionally, we have XPS blocks that is sold like a thermal insulation, and that's why located on top of the load-bearing part and below the weather shell. Then we have 3 layers of carbon textile reinforcement. So we have 2 layers for load-bearing part of the shell and 1 layer for the weather shell. Additionally, to keep the load-bearing shell to provide enough force flow inside, we have special composite rebars, combat bars, and longitudinal stirrups that provide enough load-bearing capacity along the edge beams of the load-bearing shell. Then, as it was mentioned, 2 parts of the load-bearing shell connected with a top window. In order to provide this possibility for such window, we have steel components that connects 2 parts of the shell, and these steel parts can be used like a support for the window frames on top of the building. The other important part of the project is the development of the digital model. So from this slide, you may realize that everything collected inside so-called main model. And for this model, it was decided to use Rhinoceros and Grasshopper like the main software environment. So the model in Rhinoceros is controlled by the main script developing Grasshopper. So in general, the development of the whole project is done inside Grasshopper software. So basically, the whole model is parametric. So then, because of the complexity of the twist of the load-bearing shell as it was presented before, it was not possible to collect and contain all the parametric script inside one file, and that's why it was decided using Elephant to split the code into separate files. And then you may realize from this slide again that we have a special script for the reinforcement, for the XPS blocks, for the insulation blocks, and for some other parts of the load-bearing shell. After the special development in the level 2 in these special Grasshopper files, again, the model is stored inside the same main model. And afterwards, after the preparation of the special parts of the load-bearing shell, then they can be used for the production, as you may realize from the very right part of the slide. So for the production of the EPS or XPS blocks, for the cutting of the textile reinforcement, for some special architectural design, and for analysis, for structural analysis that was shared with our partners for the structural calculation. Then the main file also collects special parts, as you may see in the left part of the slide, these additional scripts. They are specially designed to prepare data for the window frame design, then for some special steel components for the formwork, and for the other components that was requested by our partners or the partners of the project. So one more thing that need to be told is that the main script is designed to keep, first of all, the first initial concept input, the first design, the first sketch of the building. And that's why the main script, the level 1, is prepared to create very first original splines, surfaces, controlling points, and all the other components of the load-bearing shell designed from this basic component that was kept inside the main script. As it was told, the main model of the project contained all the information for the production of the constituent part of the load-bearing shell. Thus, we go to the next part, is the insulation blocks. And as it was told, we have up to 2,000 different blocks. And due to the complexity of the load-bearing shell, the different workflow in different parts of the shell, it was required to design special models, special types of the blocks. Thus, you may see the different groups from group 1 until group 7. And finally, I would like to thank you for your attention and would be happy to answer all of your questions.